On October 14, 2017, a peculiar cosmic object zipped past our planet, completely unnoticed. 5 days later, it was already on its way out of our solar system when Robert Warwick, an astronomer at the University of Hawaii at Manoa, caught sight of it using the Panoramic Survey Telescope and Rapid Response System, PANSTARRS. From the get-go, this object was bizarre. Its orbit, speed, and characteristics were all out of the ordinary. Named Oumuamua, it became the first identified interstellar object to visit our solar system. Here's the kicker. Astronomers had a mere 11 days to study this strange visitor before it zoomed away at a speed 3 times faster than Earth's orbit around the Sun, becoming too small and faint to track any longer. It exited our solar system even faster than it had arrived, never to return. Here's where things get really fascinating. While tracking Oumuamua, scientists assumed it would follow a hyperbolic orbit, influenced solely by gravity. However, the reality was different. The object's path didn't quite match a typical hyperbolic trajectory. It seemed to have an extra push, as if something other than gravity was affecting its movement. Speeding through space at 90,000 kilometers per hour, it is believed to have originated from the direction of Vega, a star located 237 trillion kilometers away. Shaped like a stretched-out cigar, by the time it was detected, it had already zipped past our Sun, executed a sharp turn, and started speeding off in a new direction. 2 specific aspects captivated scientists. First was its mysterious acceleration away from the Sun, which was hard to explain based on common theories about its composition. Second was its unusual shape. Estimates suggested it was 10 times longer than it was wide, whereas the most elongated known space objects before Oumuamua were only 3 times longer than they were wide. Following its discovery, scientific journals and global media buzzed with speculation. Was it a solid hydrogen block? Could it have been space debris? Or, as the renowned Harvard astronomer Avi Loeb proposed, was it an artificial structure created by an intelligent extraterrestrial civilization? One thing is certain. It defied our understanding of physics and left everyone puzzled. After reaching its closest point to the Sun, Oumuamua began its exit from the solar system at a blazing speed of 95,000 kilometers per hour, ensuring it would escape our star's gravity. Yet, despite its high velocity, it accelerated smoothly and steadily, unlike the erratic behavior expected from a comet outgassing its ices. The odds of such behavior from a naturally occurring comet are incredibly slim. By October 7, 2017, Oumuamua was heading toward the Pegasus constellation, moving into the unknown. With our current technology, it was impossible to catch up with and photograph Oumuamua up close, making the data we have now all we'll ever get. But all its strange attributes could have one perfect explanation. Welcome to this channel. Let's dive into it. A new study suggests that Oumuamua might actually be an alien spacecraft equipped with a light sail. An artificial origin could neatly explain the many bizarre characteristics of this cosmic visitor. Initially, scientists thought it was a comet but later reclassified it as an asteroid when no tail or fuzzy coma was observed. However, after noticing its non-gravitational acceleration, a team of researchers once again classified Oumuamua as a comet. This leads us to the study conducted by Avi Loeb and lead author Shmuel Bialy, a postdoctoral researcher at the Institute for Theory and Computation, ITC. Bialy and Loeb argue that the comet explanation doesn't hold up since astronomers still haven't observed a tail or coma around Oumuamua. They propose another natural explanation. If Oumuamua is a fragment of a larger object, its motion could be due to the initial force that broke it off. However, this kind of force would be a one-time event, whereas Oumuamua has shown repeated non-gravitational acceleration. Bialy and Loeb then proposed a new hypothesis. Sunlight might be responsible. In their study, they suggested that solar radiation pressure could account for the observed non-gravitational movement if Oumuamua is extremely thin, between 0.3 and 0.9 millimeters thick. The big question then becomes, What kind of structure could be so incredibly thin? Bialy and Loeb suggested one intriguing candidate: a light sail, designed to harness the momentum of photons for propulsion. Humanity has already demonstrated this technology in space. Japan's Ikaros probe successfully traveled to Venus's neighborhood in 2010. Bialy and Loeb further calculated that a light sail like Oumuamua could survive a long interstellar journey despite the concentrations of gas and dust in the interstellar medium and the high speeds it would encounter these particles. They determined that Oumuamua could travel at least 16,000 light-years from its home system, wherever that may be. While Oumuamua's origin remains a mystery, this is promising news for SETI, the search for extraterrestrial intelligence. Loeb emphasized that this isn't mere speculation, it's based on evidence. The anomaly in the data is that Oumuamua's orbit deviates from a Keplerian orbit, which is what would be expected if only gravity were acting on it. Viable explanations for this deviation, other than the light sail hypothesis, do not exist at this time. To be clear, Bialy and Loeb are not definitively claiming that Oumuamua is an alien spacecraft in their study, but they do consider it a real possibility worth exploring. The object could be a piece of alien space junk, perhaps a defunct sailcraft that accidentally found its way to us, or it might be an active reconnaissance craft sent to explore our solar system. The researchers wrote in their study that there are reasons to favor the latter explanation. Loeb noted that Oumuamua's discovery was itself an anomaly, as our solar system doesn't typically shed objects like Oumuamua. Moreover, Oumuamua's motion closely matches the average motion of material in our region of the Milky Way, known as the local standard of rest. This makes it challenging to determine the object's origin. Loeb suggested that if someone wanted to conceal an instrument's origin, they would place it in the local standard of rest. To investigate further, astronomers have used the Green Bank Telescope in West Virginia and the Allen Telescope Array in Northern California to listen for any possible signals from Oumuamua. So far, the object has remained silent. But regardless of its true nature, the discovery of Oumuamua is absolutely fascinating. It's a strange visitor from a distant star system, unlike anything we've ever seen in our own solar system. Here's hoping we encounter another Oumuamua soon. What do you think Oumuamua is? Drop your thoughts in the comments below and don't forget to subscribe to the channel. Together, we'll keep exploring the mysteries of the universe.